Hi, welcome to the Shiko Math Lab Mathematical Statistics Problem Solving sections. So today, the problem we're going to solve is related to the concept about complete statistics, okay, or the random variable, the distribution family is a complete family there. Okay, so today we're going to show this uniform distribution from the negative theta to the theta. This family is not complete. All right, let's go ahead and get started here. Okay, so in here we said x is belong to a uniform, right? So it's a uniform distribution from negative theta and to the theta. So based on the uniform PDF, so we know the f of x, right? So we can write the f of x, the PDF for this distribution is 1 over 2 theta. And I know that x is from the negative theta to the positive theta. Okay, so like we mentioned, this problem basically we are trying to talk about the completeness concept. So let me write here the definition about the completeness. All right, kind of like if you don't remember the completeness. Okay, completeness means, what's that means? That the only unbiased estimator of 0 is 0 itself. Okay, so here the key things that is the unbiased estimator, then is the 0 itself here. So for this problem here, okay, so now let's see here. So if we set a function, so the expected values, right? So we set h of x functions here. So this is the unbiased estimator for the zeros here. All right, so now if this is complete, then the h of x, will be zeros, right? So now let's take a look at the expected value definition will just be the negative theta to the theta and the h of x and to the 1 over theta dx here, all right? And so we can also like say because here, if it is not complete, so let's think about it. So let's say here, if I can find a function, so let's take a look at the h of x here. So now let's assume the h of x, this function is equal to the x to the 2n plus 1. Okay, so here the n could be any numbers here, 1, 2, 3, da, da, da. Okay, so you might ask why you choose this function. The reason why, because they want us to show it's not complete. So I want to find the non-zero functions here. Then if the expected value equal to 0, but the function itself is not a 0, then I will say it's not complete. So the reason why, because I see the boundary, the integration boundaries here is theta to the negative theta. All right, so now I know if I choose odd functions here, right? So then when you integrate, then you probably, so it will become zeros here. So let's take a look, see here. So this will be the negative theta. This is x to 2n plus 1, 1 over 2 theta dx, right? So you can take the 1 over 2 theta out. Then here, this will just be what? The 2n plus 2, right? Okay, so the reason why I choose an odd function, because when I do the integration, it will become even. And then the expected value equal to 0, but then the function itself is not 0. So this is 2n plus 2. All right, so now is my integrating, so it's a theta and a negative theta here. So as you can see, this is 2 theta, and this is 2n plus 2, then this is the theta to the 2n plus 2 minus 2n plus 2, then this is negative theta to the 2n plus 2. Okay, so now you can see here, because this negative, it will become what? This negative, because this the exponents is even number, so it will become theta to 2n plus 2. So that is why, and here and here will cancel out. So what happens here? So I will get this one equal to 0. That means the expected value of h of x equal to 0. And now I know, so because this is equal to 0, but the function h of x is not equal to 0. So I can say that this uniform, based on my completeness definition, so this uniform negative theta is what? Is not a complete family. That's it. It's a very very easy concept, and the problem is pretty straightforward. So just like the only kind of the key things here is, that's how I choose these functions here, because I see the integration, boundaries from negative to positive. So I know my final function after integration, if it can be an even function, then it will cancel to be a 0. So that's why I find a contradiction function. So the expected value of this function is equal to 0, but the function itself is not a 0. So I know this family is not a complete family. That's it. It's a pretty, okay, so it's a pretty fun problems here. All right, so have a good day, and I will talk to you for our next problems here. Bye.